రెండు సైడ్ పెట్టండి కామెంట్ బాక్స్. Hello dear students, welcome you all to the last and final session of NEET 10, a game changer, a challenger program by Sri Chaitanya. Myself Dr. Pavan Kumar Kasu, I am your chemistry mentor, discussing the concepts of chemistry which are very useful for the NEET and other examinations for the last 9 sessions. So today incidentally the last session of this entire course, and hope you guys have thoroughly enjoyed and learnt all the important concepts through the FAQs. Now it is the time for us to discuss some more questions and understand the concepts, so that tomorrow when you are writing your final examination, you don't commit mistakes or you commit as low mistakes as much possible. Because you know that when we finish our exam, when we end up our exam, when we come out of the examination hall, when we check the key, we notice that we made blunders. So these are usually called as silly mistakes. That means knowingly or unknowingly we will be committing the mistakes in the questions that we already know the answer for. So that type of mistake correction should be the agenda of your talking about polarity of the molecule. You have to account for what? Dipole. So dipole moment is the sole criteria to determine whether a compound is polar or non-polar, isn't it? What I mean to say, that if you have any compound which is having zero dipole, you know you will be calling it as what? Non-polar molecule, isn't it? However, non-zero dipole, you define that as a polar molecule. So this is the general trend in determining the polarity of a given molecule, right? Now you check the molecules which are given to you. You can see this itself is not having any polarity because there is no electronegativity difference. No electronegativity difference. So this cannot be the right answer, because this compound does not have the, you can see, non-polar molecule, polar bond. This is non-polar, but the point is it does not have any polar bonds, because the bond is between two similar atoms, isn't it? What do you say? Now what about H2O? You know that H2O, because of the lone pair of electrons that are present on the oxygen atom, it tends to be bent in geometry. If it is bent, not linear, you could anticipate this to have some net dipole moment in the direction of the oxygen atom. So this is not what you call non-polar, rather water is polar. So water is polar with polar bonds, isn't it? N2, you know, is non-polar with non-polar bond. So only one option left out is nothing but BF3. What do you all say? BF3, you know, boron fluorine bond is very much polar. However, the net molecule is non-polar because the resultant dipole of the two fluorine boron bonds is exactly nullified by this boron fluorine bond. So net dipole is 0. So this compound is non-polar. So it's a non-polar molecule with the polar bond. So right answer for this question should be, what is, are you there with me? Very good. Rebecca, you are the first to give the answer. Come on, what is the name? IUPAC nomenclature. You can see that it's a repeated question. Remember, when you are talking about the nomenclature of the cycloalkenes, numbering always starts from the double bond. And after that, lowest locant or sum of the locant. Remember this point and proceed accordingly. All right. You can see here, if I am numbering from here, you have only two choices. You can number from this bottom carbon so that you can see the sum of locant is 3 plus 5, or you can number it from here. I will use some other ink so that I can number it from here. You can see 1. To number it like this. So, sum of the locant is correct with yellow ink, isn't it? Lowest from this carbon. Therefore, this numbering is incorrect, isn't it? I will remove this numbering. So, what is the name of this particular compound? According to alphabetical order, Raghavendra, what should be the name of this compound? You can see there is a substituent at 5th position and nitro at 3rd position. What is the answer? Alright. Nitration of benzene. You can see we are carrying out the nitration of benzene with nitric acid requires the use of concentrated sulfuric acid. This is nothing but the concept of what you call nitration. When you carry out nitration, you will be using the nitration mixture, which is obviously the mixture of concentrated HNO3 and H2SO4. Now, what does it say? The mixture of concentrated HNO3 and H2SO4 produces the electrophile NO2. Looks to be alright, isn't it? You know the mechanism of the reaction. Please understand. If you take HNO3, the H plus ions from H2SO4 are going to produce NO2 plus. So, the purpose of taking the acid is to act as a catalyst or base, acid to remove from HNO3, which is a base, to produce NO2 plus. Alright. So, you can see that it makes sense that this NO2 plus is formed by the mixture of concentrated HNO3 and H2SO4. That's a good answer. Which among the following is least electronegative? That means we are talking about usually what? The least electronegative or most electropositive. The one which is having most electropositive nature is aluminum. Tilak, good job. Next, yeah, iodoform test. You know iodoform test, isn't it? You should either have CH3 C double bond O group or CH3 CHOH group. Now, with this knowledge, I don't see any scope for the failure of yours. You guys are doing really good, especially Rebecca, Arjun Reddy, Tilak, Raghavendra are doing really good. Krishan Datta. What's the answer for this? Dimethyl ketone. Okay, are you talking about the previous question? You have to write the structure so that you can understand whether this has that arrangement or ethanol, right? So, again, see that it's an aldehyde with this arrangement. So, ethanol gives diphenyl ketone is not given by diphenyl ketone. You can see you don't have any such unit. Alright, so what should be the right answer? You still say D. What about the ethanol? You have CH3 CHOH. It could be an alcohol, aldehyde or ketone with this arrangement. Dimethyl ketone has that arrangement. Remember, this arrangement is mandatory so that you can write the iodoform test. Yes, Rebecca. So, this is the compound which does not have that unit. So, what's the answer for this question? Krishan Datta. It's a mistake, buddy. Isoelectronic and isostructural have same number of electrons and same structure, isn't it? Let's check. So, you can see when we are talking about the same number of electrons, both the elements falling in the same period would have the similar number of electrons depending upon the negative charge. You can see one is carbon, the other is sulfur. They don't belong to the same period, isn't it? So, there is no scope that they will have the same number of electrons. So, So, is no scope, buddy. So, these two are not possible. Sulfur and nitrogen not possible because they don't belong to the same period. They are not closer either. So, you can't expect them to have same electrons. You can say chlorine carbon, same is the case. They cannot have the same electrons. However, chlorine and sulfur, they hail from the same period, isn't it? So, electrons can be closer. Okay. Bhavishya said A. Let's check the total number of electrons, isn't it? What do you all say? Total number of isoelectronic, right? Total number of electrons and isostructural. First of all, let us write the structures of these. CO3 minus 2, alright, is planar, trigonal planar. And because of the lone pair of electrons on the sulfur, this is pyramidal, isn't it? We know how to predict the structures. I did not say this at this point of time. So, SO3 minus 2 is what you call pyramidal. So, SO3 minus 2 pyramidal. NO3 minus is what? 5 plus 1 by 2, that is sp2 hybridization. This is planar. So, this is pyramidal and this is planar, not matching, isn't it? Now, ClO3 minus is pyramidal because there is a lone pair, and CO3 minus 2 is planar. I can see this is pyramidal and this is pyramidal. So, we have predicted that since they both belong to the same period, they will have same number of electrons, and also they are having what? Same. You are right, Rebecca. It should be correct answer. Well done. Good job. Bhavishya, you said A. I don't know what basis you said A. You please check your answer once. Predict the product in the given reaction. I told you multiple times that whenever the reaction based questions are asked, zoom into the functional group. Check which functional group is present. You can see the functional group is aldehyde. Aldehyde with concentrated base, you have two reactions. One is aldol, the other is Cannizzaro. For that, you need to check whether the compound has alpha hydrogens or not. If it has alpha hydrogens, aldol. If it doesn't have alpha hydrogen atom, it is Cannizzaro. You can see that benzaldehyde and its derivatives does not have alpha hydrogen atom. So, you can expect this to be what? Cannizzaro reaction. So, Cannizzaro, it's a disproportionation reaction where one mole of the aldehyde gets oxidized, the other mole gets reduced without disturbing this group. You can see this could have been the case, but you can see chlorine is gone. Chlorine will not go anywhere. Alright, chlorine is not replaced by OH either. Only in this case you can see that one mole of aldehyde is reduced and the other mole is oxidized. So, it is a Cannizzaro reaction. So, it is a frequently asked question. So, based on the alpha hydrogen atoms, you need to answer this. Alright. Among the following amines, the strongest base is. While predicting the strong bases, even in our yesterday's rapid fire session, because we had to discuss 1 minute per question. So, we have done it around 50 questions in 60 minutes. Now, yesterday also I have discussed this type of questions, right? In that I said, if you remember, the strong base is the one in which the nitrogen lone pairs are not in resonance, isn't it? If you want it to be stronger base, it should not be involved in resonance. And next point is that it should be saturated nitrogen. Unsaturated nitrogen does not donate so easily, isn't it? Now, based on this, you can see in these cases the nitrogen lone pairs are involved in delocalization. You cannot expect this to be very much aromatic. So, as the case over here, you can see this is also involved in the resonance. So, these two are weakly basic. Coming on the comparison between, Datta, what do you say about these two? Which one is more basic? You can see that this is alkyl group which is binding this nitrogen atom in a ring, shows plus psi effect. So, among the two, you can predict that there is no resonance on the nitrogen atom and it is saturated. Therefore, Rebecca, answer should be D, Delhi. Copper plus 2, Ni plus 2, Zn plus 2 in acidic solution, then the ion that is precipitated. You know, you have studied what you call the salt analysis, in which you should know that the salts of NiS and Zn, which are being precipitated in the form of what you call their sulfide, all right, are very less soluble in water. Okay. And indeed, you should also know that nickel sulfide is dissolved by using aqua regia, right? You know that reaction. HNO3 plus 3HCl gives rise to NiCl2 plus S plus NOCl and water. So this clearly tells you the story that the precipitates that are formed by nickel and zinc are difficult to dissolve. So only option left is copper, buddy. Okay. The copper precipitates are easily soluble in water for the reason that copper plus 2 is stable in water. Remember this. Why it is stable in water? Because it has got excess of heat of hydration. That's the reason why you would find most of the time the copper salts are soluble. That's how it forms the precipitate, copper ammonium precipitate, copper water precipitate. So this is the trend with copper. Lassaigne test. You know, you have studied Lassaigne test, isn't it? What will happen in the Lassaigne test is that the detection of extra elements would take place, like, you know, because you can see in all the examples which they have mentioned, they had given you what? Nitrogen atom. So if I consider this as the analysis for the nitrogen atom, what would happen when you are heating your organic compound by adding a freshly cut sodium? If your compound has nitrogen and carbon, it will form sodium cyanide, and this is added FeSO4 so that you can get FeCN taken twice, which will be added excess of NaCN so that you get Na4 FeCN taken 6, which is further added FeCl3 to ultimately give you a Prussian blue complex of this formula, isn't it? So this is the whole reaction sequence that you would come across in the nitrogen atom. For that, you see, to start with, your compound should be having what you call the carbon and nitrogen. Rebecca. So you can see all the compounds have carbon and nitrogen. You can see, right? Carbon and nitrogen. Except what? Hydrazine, which does not have any carbon. So this is not applicable. Remember this. This is not applicable to the compound which does not have carbon. So this is a very important concept. Amphoteric oxide, easy question, isn't it? You should remember, usually basic oxides are metallic oxides. You can see non-metallic oxides are acidic, and not all basic. In fact, aluminum oxide, you know that it's going to react with, you have studied, right? You know, in particular you need to remember ZNO, SNO, SNO2, all right, Pb related salts are usually amphoteric by nature. That means they could react with the strong acids as well as strong bases. Okay, so you consider them as amphoteric. You know, it's a basic question, isn't it? Sometimes the questions are crazy, isn't it? In NEET, if you're fortunate enough, out of 45-50 questions that are asked, let me tell you 30 would be easy from NCERT textbook. So please be watchful tomorrow. Incorrect statement, you can see one of such question straight away from your NCERT textbook. If you read the textbook, you can answer this question. All Bronsted bases are Lewis bases, isn't it? Because Bronsted bases is proton acceptor. To accept the proton, it should donate the lone pair. If it donates the lone pair, it is Lewis base. Good. Ionic product of water is temperature dependent. Yes, certainly. Ionic product varies with the temperature by using this formula. K2 by K1 equal to delta H of vaporization by 2.303 R into 1 by T1 minus 1 by T2. So this is the equation pertaining to the variation of Kw with temperature. Yes, that's true. Lassaigne principle is applicable to both physical and chemical equilibrium, right? Cooking food in a pressure cooker or converting or what you call shifting the equilibrium of H2O solid to H2O ice by using what you call pressure and temperature. It's a physical equilibrium. So Lassaigne principle is applicable to the physical equilibrium also. The only one thing is not looks to be correct is this relationship. You can see the relationship we have studied is Kp equal to Kc into RT whole power n, whereas it is given as Kc equal to Kp. You need to be watchful, buddy. Yes, Rebecca. Good. Let's see the next question. Stoichiometry. In every exam there is one question which you don't feel like solving, but if you observe this question, they are basic, absolutely basic. Mole concept only mostly. The weight of iron which will be converted into its oxide by the action of 18 grams of steam. Write the equation, balance it, convert the mass into moles. Finished. Fe plus H2O, Fe3O4, you need to check what product is obtained. Sometime it will be Fe2O3. Write the equation, balance it, since Fe3O4 is given, and 4 oxygens, 4 hydrogens. Now what is the impact over here? You need to calculate what? 18 grams of steam, that means how many? Mole. 18 gram, 18 by 18, that is 1 mole, isn't it? What do you all say? Datta. So you can see 4 moles of H2O versus 3 moles of iron. 1 is to 3 by 4. 4 is to 3 means 1 is to 3 by 4. That's all. Iron reacted is 3 by 4 mole. 3 by 4 into mass of iron is 56. Simple. Alright, you can do that, right? So it seems very easy. When you simplify, you will get 42 gram. Got it? A salt solution on treatment with H2SO4 gives out a gas which turns K2Cr2O7 paper green and lead acetate paper black. The salt contains. It's quite natural, right? You can see that we are talking about the reaction of a particular anion with dilute H2SO4. Carbonate with dilute H2SO4 gives what? You all know, you haven't studied or what? You know, when this reacts with dilute H2SO4 gives rise to CO2 gas. CO2 does not decolorize K2Cr2O7, isn't it? You cannot anticipate this reaction to take place. Ruled out? Isn't it? What about chloride ion? Chloride ion reacts only with concentrated H2SO4 but not with dilute. This is not detected by the dilute H2SO4. Ruled out. Next, nitrate. Nitrate also, when you take nitrate and treat it with H plus, the gas obtained is NO, which will be later converted into NO2. It will not give what you call the lead acetate paper black. If it is lead acetate paper black, yes, you got it, sulfide. So what's happening here, that when this is treated with H plus, H2S is obtained. And you know H2S, it's reducing by nature. What it does is that it's going to reduce the dichromate into Cr plus 3. This is a very popular reaction, and also lead acetate into black color. So you guys can easily make out. You can see that since the time of its induction, 1 to 2 questions are asked from salt analysis. So don't skip it, read it thoroughly, buddies. Which of the following actinoid show the oxidation states up to 7? Looks to be there is a mistake in this slide. So excuse me here for a while. That looks to be that there is a problem with the slide. Some option is missing, right? Option should be neptunium, because as far as I know, It should be neptunium. Let me write here. The correct answer is neptunium, whose atomic number is 93. All right, 93. So it is like 5F4, 6D1, 7S2, 4 plus 2, 6 plus 1. Yes. All right. So it goes like this, because you know atomic number 86 is that of radon, and plus 7 oxidation state is possible for neptunium. So this is wrongly printed. You should excuse us for this. Have you understood, Rebecca? You are there with me throughout the class. Bhavishya added. Kartikeya. You see the right answer, even though option is not mentioned correctly. You can see the question, buddies. KSP of AgCl in the molar AgCl in AgNO3. Listen to me, it's an important thing. See what is going to happen here. Listen to me. You take AgCl, which is a weak electrolyte, isn't it? You know that AgCl is a precipitate. It's a weak electrolyte. Okay. And you have taken that in a strong electrolyte, AgNO3. Plus NO3 minus. You can see whatever concentration of Ag plus that we find from AgNO3, because you know that AgNO3 is a strong electrolyte. This dissociate completely. So when you write concentration of Ag plus, you should write it from AgNO3 but not from AgCl, because of common ion effect. Isha Reddy gave the answer also. Maybe you are right. Brilliant. You know, when you write because of the common ion effect, concentration of Ag plus obtained from AgCl is pretty low. Therefore, you should take Ag plus obtained as if 8 into 10 to the power minus 12, as if it is obtained only from AgNO3 into concentration of Cl minus, which is nothing but the solubility. So solubility is turning out to be how much? 8 into 10 to the power minus 11. Yes, simply you got it. For you also, buddy Kartikeya. For you also, all the best. I know you can do pretty well. See, we are talking about the first order reaction. For first order reaction, T half versus concentration is constant, because you know it is 0.693 by K. It's a constant value, isn't it? So it's constant, so the graph should be like this. This cannot be the right answer. Concentration versus time for a first order reaction is a straight line, because, isn't it? Concentration versus time. You should always know one relationship, buddies. T is inversely proportional to concentration raised to the power n minus 1. Please understand and remember this relationship. So only one thing which is matching to that is this, because you know for that reaction K is equal to, how would you write, 2.303 by T log initial concentration of the reactant by final concentration. So when you are writing it as log of R naught by R equal to K by 2.303 into T, that is Y equal to M into X. So you can see that is perfectly matching only for this. Good. IUPAC name for the compound which we already wrote now. Isha, come on, tell me the answer for this question. You should know that the oxidation number of the inside iron is 2, outside iron is 3, isn't it? So what's the compound? Ferri. Alright, it's mentioned as iron 3. Iron 3 in all the questions, right? Hexacyanoferrate, 2 outside 3, inside 2. That's perfect, Rebecca. Good job. An organic compound A on treatment with benzene sulfonyl chloride. Benzene sulfonyl chloride is called as which reagent? Hinsberg reagent, right? benzene sulfonyl chloride is called Hinsberg reagent. So this react with a primary amine basically. Let me explain this for you. So it reacts with a primary amine. So what's going to happen when it reacts with a primary amine? You're going to remove the HCl, primary amine. So when you remove the HCl and when you write the end product, you can see the end product. What do you get here? Benzene SO2 NH primary amine. I'm writing some alkyl group here. So you can see this hydrogen atom by nature is still acidic because this negative charge is resonance stable with this SO2. So it can be extracted readily in KOH. That means when I treat this with KOH, I would be getting a salt. I'd be getting a salt, isn't it? So this clearly shows, but that's okay, you are still doing better. You can take time in such type of questions. You can see based on that the answer, this is a 3-degree amine, this is a 3-degree amine, this is a 2-degree amine, and this is a primary amine. So your answer should be D daily. Isha, you got it. That's so brilliant. Wrong match. Tell me what could be the right answer then. Come on, speed up. Magnetic property is based on number of unpaired electrons, right? Come on. Answer this question, Isha. You are really good, doing good, but speed up. Wrong match. Isha said D. Please check your answer, Isha. Rebecca also said D. Is it not KMNO for purple? Isha, you gave 2 answers. You should pick the wrong answer. You need to understand here, manganese is not +7, mistaken. +6 has an odd electron. So nothing is wrong in saying it as paramagnetic, and it is of course green, dirty green rather. Wrong match. Come on, check. Datta. Yes, it is para. Who says no? It is paramagnetic. That's true. No, speak out. I'm waiting for your answer. You guys are really good at giving good answer, right? So you can see that K2Cr2O7, is it yellow? We all know that it is orange in color. And remember, because chromium in +6 oxidation state does not have any unpaired electron, that is diamagnetic, but that is not yellow. Remaining all are correct. Manganese is in +7 oxidation state is diamagnetic, doesn't have any unpaired electrons, but is what is yellow? K2CrO4, and you can see the oxidation state of this chromium is +6, 0. Got it? No, KMNO4 manganese is +7, it is diamagnetic. Is that okay? Rebecca, have you understood, Isha? Yeah. Oxidizing power increases in this order. It is due to increase in stability of the species where they are reduced. Yes, that is certainly true. Alright. I believe this is correct. Both are correct. Yes. Because the stability of the product is more. That is actually reason. Now you see this very popular reaction. We have been seeing this reaction for quite a long now. You can see what is happened here. What happens here is mid reaction, right? Ortho product, because there is sodium. Remember, if there is sodium, there is ortho. Potassium gives you para. So salicylic acid derivative you will get. And when this is subjected to what you call acylation, you can see you are using what? Acylation. O-acetyl salicylic acid, which you commonly call as aspirin, isn't it? Okay, very good. Option A, brilliant. You got the answer within no time. Structure when you are predicting the resonating structures, remember, first preference people commit mistakes here. Octet of all atom must be complete. Then electronegative element should have negative charge. These two conditions you have to remember. Octet of all atom is complete and no negative or positive charges here. So 1 should be greatest. So these two options are ruled out. Alright. Then next, in the next case, what is happening here is that oxygen having a positive charge is something which is not acceptable. Alright. Oxygen having positive charge is something which is not acceptable. If the resonance happen, it will happen this side. In acrolein is the common name of the compound. That means when you are writing here resonance in this compound, give me a minute please. When you are writing resonance in this, you know that the shift is going to take place upwards to give you CH2 plus CH double bond CH O minus. So these two are the prominent resonating structures of the acrolein. So you can see where there are no charges is 1. Then comes oxygen with the negative charge, right? Electronegative with negative charge. Looks to be that is present in, yes, you are right, B. The total number of metal-metal bonds present. Can anyone guess? Very important, isn't it? Frequently seen compound. Don't get confused between carbon monoxide and cobalt. You know, 2 carbon monoxide units are shared between the 2 cobalt units. So this is actual structure. Prabhakaran, you are back and you can see there is 1. Yes, that's good. Predict the major product of the following reaction. We have been repeatedly discussing that it's not so easy to break the bond of the oxygen and benzene because of the resonance. So this has the resonance, so bond energy is high. Remember this. If the bond energy is high, you can't break it. So it's better you break this bond. So you have H here, Br here. Alright. So compound A, when treated with HBr, ethers, frequently seen compound, OH plus C2H5Br. Alright. So this is your A. Isn't it your A? Yes. And after that, when you are treating it with the concentrated HNO3 and H2SO4, that is nitration, where you know that OC2H5 is ortho-para directing group and this is nitration. Nitration is going to take place at ortho and para, preferably para position. It's not that ortho will not be formed, but because it's a bulky electrophile prefers para position. That's brilliant. Isha, the answer is B, Bombay. Alright. So hope you guys had a great session and it was wonderful discussing the subject with you, especially some of the students like Rebecca, Prabhakaran, like Ashley Talks, Anish, Arya, Raghavendra, Isha, Prabhakaran. Really wonderful time. Thanks for making these sessions go really well. I wish heartfully a great luck in the upcoming NEET examinations. Thank you.